Now, this is just learning a new notation. So, we're going to have a function f of x and a function g of x, for example, and we're going to see stuff written like this. This is f plus g of x, which literally is equal to and just means take f of x and add it to g of x. We know how to add functions, don't we? So pretty easy. Now, what a lot of people will do is they'll say, well, what about this times x? That's not a times x, guys. This literally just means we have a function f plus a function g, and they're both functions of x. So this just means f of x plus g of x. Everybody good? So look, f minus g of x, we know how to subtract functions, so that's literally equivalent to f of x subtract g of x. So why I put a red flag right here is because when with subtraction, when we're subtracting g of x, we need to use parentheses so that we don't forget to distribute the negative into all of g of x. F times g of x is just literally f of x times g of x. You could see it written either way. Just depends on the problem. Then f divided by g of x is f of x on top, g of x on bottom. And we know that with these answers, remember back to the last unit, with this type of answers, we also have to include the denominator cannot equal 0, right? From our last unit, rationals. Everybody good? We know we can't divide by 0, so we'd say our denominator cannot be 0, and we would state that. So here we go, off the worksheet. We're given f of x is 4x minus 1, g of x is 2x squared plus 3. It says find f plus g of x, which literally means take f of x and add it to g of x. So that would be 4x minus 1 plus, and with addition, we don't have to be careful because there's not going to be a distribution. So now just combine like terms. So 2x squared, no other x squareds, plus 4x, plus 2. That is f plus g of x. I always have people ask me, should I factor it? And then I ask them, well, if you factor it, is that any better than having it in standard form? No, they're equal. So why do extra work? Simplify, what do you mean by simplify though? Remember that simplify means divide things up. I don't know. You know what I mean? Like simplify. Factoring doesn't mean simplify though, right? Because they're equivalent, everybody? So just a reminder. Okay, let's do f minus g of x. Okay, this is one that we've got to be really, but you know what a lot of people ask? This is actually probably what, when I heard a few people out there saying, oh, should we simplify it? This is what somebody asked me last hour, and it was a really good question. They said, should I divide out of 2, Miss Christensen? Well, then we've changed the problem. We could factor out of 2 and leave the 2 out in front, right? It can't magically disappear, but why factor when we can leave it together? Does that make sense? Okay, great. So f minus g, here we go. 4x minus 1. Then now we've got to subtract, parentheses, all of g of x. So 2x squared plus 3. All right, so isn't this really subtract 2x squared minus 3? Boom, boom. And now this is gone, so combine like terms. So we have negative 2x squared, no other x squareds, plus 4x. Good, minus 4. There's our answer. Okay, you guys do, well, actually, yeah, you guys do number 3. Ready, set, go. By yourself. Did you get it right? Right here. 2x squared minus 4x plus 2. So this, you're telling me should be a 4. Good point. I make mistakes. I've never claimed otherwise. Okay, everybody, look at number 4. F times g of x. Now, with multiplication, we are going to need parentheses if there's 2 terms. So f of x is 4x minus 1. And then g of x has 2 terms, so you need parentheses. 2x squared plus 3. Ready, set, go for it. Somebody I just heard said, they said 8x cubed, continue, whoever's saying this. What? You're correct. All right, now let's look at f divided by g of x. Now I'm going to scroll up, but you have f and g on your paper there. So f of x goes on top. So everybody on top, we would have 4x minus 1, and our g of x is 2x squared plus 3, correct? Now remember, with division, we would simplify by factoring the top, factoring the bottom, and dividing out exact factors. The top is linear, and it's already good to go, isn't it? Let's check the bottom. Just watch. What multiplies to be a times c, what multiplies to be 6, and adds up to be 0. 3 times 3 is 9. So unfortunately, it doesn't factor, correct? Well, not unfortunately, because that means it doesn't simplify. Yay for us. Okay. Now, would it be appropriate to divide across an addition sign? Heck no. Okay, good. Now, that's our answer, but we do need to put in, well, we know because it's division, we can't divide by 0. So isn't it a true statement to say, okay, 2x squared plus 3 cannot be 0? The denominator cannot be 0, everybody. Let's solve for x and see what x is going to make the denominator 0. So shouldn't I subtract 3? 2x squared equals negative 3, then divide by, so we have x squared cannot equal, sorry, that was a cannot equal, negative 3 halves, then what? Square root. Now doesn't that actually come out to be plus or minus I root 3 over 2? Well, we're not going to be plugging in i's, people. We're only talking real numbers here. If you graph this, we don't, on an XY chart, we don't graph i's. It's only real numbers. So we're never going to have that happen. That I is, we're not going to plug in I. Do you see that that's the value that would make the denominator 0, right? We're not plugging in I. So this one has no restrictions. That denominator will never be 0 unless we plug in I. Root 3 over 2. We're not going to be plugging in i's. So this one has no restriction. That's our answer. Now you'll see that in 6 though, there will be a restriction. So now instead g is on top. So we have 2x squared on top plus 3. Now on bottom we would have 4x minus 1. Now that's our answer. We know it doesn't factor and divide. We already tried factoring this, so that's our answer, but we do have to say what x cannot be. So we would say 4x minus 1 cannot be 0. Solve for x. Yep, so we'd add 1. So we have 4x cannot be 1. So then x cannot be 1/4. If we plug in a fourth, we get 0, everybody. That's a problem. So that's our answer as long as x does not equal 1/4. Remember that we did that in the last unit. Okay, awesome. Now next thing to note, we are asked in these instructions to find the domain. Now we would the easiest way to think about domain is by looking for potential problem areas. So now everybody, looking for restrictions is essentially what we're looking for with domain. So there's a couple things to think about. Domain is what x values are going to be on the function if we graph this. Does that make sense? So, or what possible x values can we plug in? So it's easiest to look at domain by just looking for, I call them potential problems or restrictions, because those won't be in our domain. So you should be writing this down. The first restriction when dealing with domain or possible x values is first look for the problem of dividing by 0. So if it's a division problem, there will be a restriction in the domain. It's when the bottom equals 0. That will have to not be in our domain. So that's the first problem you look for. If you're dealing with a division problem, your domain is going to have restrictions. Does that make sense? So everybody look right here. Let's state the domain on this example right here. So isn't it true, since it's a division problem, that the denominator can't be 0? So x cannot be 0, correct? All right, then what's our domain? Well, the way we write it in secondary 3 is just to say we can have any real number. Now, why do I say real? Because we're not plugging in imaginaries. We can plug in any real number into this function, except We cannot plug in 0. Now that is like a fancy R, so it's like a double line and then an R. That just means all real numbers. Real meaning not imaginary. Now if you're going on to pre-calculus, this is not how they would write it. So most of you need to write it in the more advanced notation, interval notation. So now think about it, you guys. We can have any other x value except 0, correct? So I can plug in negative 100, can't I? Can't I plug in negative 1,000? Okay, you get what I'm saying though. And then I can plug in, so I can plug in negative infinity up to 0. I can't plug in 0, so I put a parenthesis. That means not 0. Union, then from 0 to infinity, that's okay in our domain, just not 0. You see how that would connect it all, and then that's jumping over 0. Okay, sweet. All right, that's interval notation. That would be the more, a lot of you are advanced thinkers. You should write it like this. Okay, let's look at another one. So you say, oh, a division problem has restrictions in our domain. X cannot be 3 or negative 2. So our domain is all real numbers except 3 or negative 2. And if you're an advanced thinker, you would say, okay, I'm going to put that in interval notation. We've got to connect all of our x's together, but we've got to tell it can't be 3 or negative 2. So we're coming in from negative infinity up to negative 2, and then we jump over negative 2, don't we? And continue onward. So then union, it's going from then negative 2 up to 3, and then it's jumping over 3. Union just means like and. So it's jumping over 3 and then going to infinity. So this would be the pre-calculus / calculus notation. Does that kind of make sense? Cool. Some of you should push yourselves to write it like that. All right, so when dealing with domain, if it's not a division problem, it's all real numbers, okay? Problem number 1, that's what we look for. Now here is problem number 2. So problem number 2 is when we have answers that contain square roots or radicals with an even index. So recall that when dealing with square roots, we just talked about we're not going to be plugging in i's. Like we're not going to be plugging in we're not going to have i's. We can't graph i's on a real number line. So when having a square root in your final answer, there is a domain restriction. Now think about it. So I'm going to ask you a question. Can I plug in negative 1 right here? Square root of negative 1. That's not going to happen. If we graph this, that would not happen. So what's going on here? Well, we just can't have something negative under the radical. So look what I put. A negative thing under the radical is bad. Now here's what we have to remember though. A lot of people get caught up in this. The square root of 0 is equal to 0, which is great. That wasn't imaginary. 0 is a number. So we can't have a 0 under a square root. So now think about it. If it can't be negative, but it can be 0, wouldn't it be from 0 to infinity, everybody? All the positive numbers for x. So what we would do is say, okay, for this, what's underneath the radical has to be greater than, so x has to be greater than or equal to 0. Now look, let's see why that makes sense. What's a number greater than 0? 1. Square root of 1, is that okay? 2, 3, 4, 5, 6, 7, 8. Yes, I can plug all those things in. But watch, if I go below 0, negative 1, it's a problem. Does everybody agree? Now, plug in 0, square root of 0, 0, that's all good. So does everybody get that? Okay, so then do your interval notation just for those of you going on to pre-calculus. So 0 is included, so you put a bracket. That means starting at 0, all is good, up to infinity. That would be our domain. And guess what? I promise you that's true. If you were to graph this, and we'll learn this in a couple of units, it would literally look like this. It starts at 0 and grows to infinity. So our domain is true. It's easier, though, to look at it with restrictions instead of having to graph it. Okay, so look at this one. We would have to say for our domain here, x minus 4, what's underneath the radical, must be greater than or equal to 0. Now solve for x. So I'd add 4 over. So x must be greater than or equal to 4. Now think about why that is true. If I plug in 4, what's 4 minus 4? 0, which is good. If I plug in 5, 5 minus 4 is 1. Is that good? Yeah. If I plug in 6, 7, you see how that's all good? But watch what happens when I plug in something below 4. 3 minus 4 is negative 1, which is I. That's not going to happen. Does that make sense? So our domain would be from 4 to infinity. In interval notation, if you want to write it like that. Okay. So there's those two problems. If there's no radical and there's no division, the domain is all real numbers because there's not a problem that we would restrict. So let's go back to the front page here, and let's go back and do the domain since that's what it asked us to do. So I'm going to write in red, I guess. Okay, look at your answer here. Do you see a division problem? No. Do you see a radical? No. So there's no restriction on your domain. So domain is all real numbers. Or in interval notation, that's equivalent to negative infinity to infinity. Does that make sense? There was no radical, correct? There was no division, so there's no restriction. Now think about why that makes sense. If you graph a quadratic, won't it grow forever to the left, forever to the right? Yes, so it's all real numbers. Solving is where it crosses the x-axis, though, right? Which will be in our domain. Yeah. Okay, so let's look over here. Was there a problem in this answer? A division problem? No. Was there a radical? No. There's no restrictions then. The domain really is going to grow from negative infinity to infinity. Or all real numbers, however you prefer to write it. Okay, let's look at 4. This answer did not have a division problem, and it also did not have a radical. So if you graphed it on your calculator and looked where it was growing, it really would be growing from negative infinity to infinity, because there's no problems. So your domain is all real numbers, or negative infinity to infinity. Does everybody get the gist here? Okay, now looking at these division ones, we'd already determined that the denominator can't be 0. We went through and tried to solve, and it didn't ever happen, correct? So the domain here, because the restriction didn't actually end up happening, would be all real numbers. We can plug in any real number. Because we said it was I, that would make it 0. We're not plugging in i's. I's are not graphed on a number line. But right here, we said x cannot be, now remember, domain is x. X cannot be 1/4. So let's write our domain. Our domain would be all real numbers, except x just will not be 1/4. So what's going to happen in interval notation is it's going to come in from negative infinity up to 1/4. It's going to jump over 1/4 and continue onward. Union of 1/4 to infinity, because we can plug in anything else. So if you're advanced, do that. Yes, you are. Here we go. Does everybody kind of get it?
Yeah.
I can't tell. Okay, cool. Okay, let's go to page 3. Flip over to page 3. I'm about to let you work all by yourself. I pinky promise. You guys are doing good. Stay with me for just one more example here. So it says 1a, find f minus g of x. Don't say, oh, times x. No, this is just f of x minus g of x. So take f of x, which is x squared minus 1. Then subtract, we need parentheses, all of g of x. So subtract 2x minus 3. So then we'll distribute the negative through, won't we? So this becomes negative 2x plus 3. So then combine like terms, x squared, no other x squareds, minus 2x, plus 2. We just found f minus g of x. Now what is the domain? Do you see a problem? Division? No. Radical? No. So what's the domain? Good, all real numbers. Okay, let's go on to part B now. Part B says, I want you to take f minus g, but instead of x, I want it to be of 3. So what do you suppose we would do here? Yeah, plug in, insert, you're all right. Both of you are correct. We would take, instead of an x, it's saying, I want 3. So look, we know what f minus g is, but now instead of x, we want 3. So you would do 3 squared minus 2 times 3 plus 2. Let's calculate that. So that's 9 minus 6 plus 2, which is 3 plus 2, which is 5. Now, people always ask me, what about domain here? Well, we're not talking domain because there's not a variable. We're calculating what's the function at 3. Does that make sense? There's not a domain. Not a function, it's a value. We combine -1 plus 3. I'm going to plug it in down here in the simplified answer, because that'll be quicker. Right. So part B, we took, instead of doing f minus g of x, which is this, right? We did 3. So right here, plug in a 3. Valid question. I actually did have people last hour go through and do this. They went right here and they went 3 squared minus 1 minus 2 times 3 minus 3. But that's a lot harder than just putting it in the simplified function. Does that make sense? You would get the same answer. It's just a lot more room for error there. So that's what you were asking. That makes sense of what you were asking. Okay. You guys do 3A and B. Ready, set, go. What did you get for A? Okay. Good. And what was your domain? Okay. Good, because there was no problem, so you're right. And then what was F plus H of 0? 0. We did 0 squared minus 4 times 0. Very good. Awesome job, everybody. All right, let's look at G7A. G divided by H. So G is on top. That would be 2x minus 3. And H is on bottom, which is 1 minus 4x. Then we simplify by factoring the top, factoring the bottom, and dividing out exact factors. But nothing's going to factor, right? So we could reorder this and go through all that trouble, and we absolutely would not be wrong in doing that. We'd be extra awesome if we did, but I already know if I pull out a -1, it's not going to divide out still with the top, so I'm not going to go through the trouble, but it's not that you'd be wrong. It'd be that you're being extra good, okay? All right, so then from there, let's restrict, because we know we have to with division. Isn't it true to say our denominator can't be 0? 1 minus 4x cannot be 0. Solve for x so that we know which x is restricted. Subtract 1. So we have -4x cannot be -1. Then what? Divide by -4. So then we know the 1x value we cannot be is 1/4. So we would say that's our answer as long as x does not equal 1/4. And now the domain is really easy since we've done that restriction. That's the only x value that is a no-go in our domain. So let's write it in the advanced way. We're coming in from -infinity up to 1/4, not including a fourth, jumping over it, and then starting from a fourth to infinity. Okay, now let's do part B. G divided by H of 0. A lot of people will say, well, we can't plug in 0 because we can't divide by 0. But we already said this is our only restriction, so we can plug in 0, right? Okay, so here we go. G on top was, so we would have 2 times 0 minus 3. On bottom, 1 minus 4 times 0. Good, so on top we have a -3, correct? On bottom we have a 1. So yep, your final answer would be -3 over here. Go ahead and finish up that section. Second, number 8, here we go. So it says f minus g of x, so f of x minus g of x. So that'd be 2x minus, oh, 2 terms, I better use parentheses, root x minus 1. So then we would make sure to distribute the negative there and there. So that is plus root x plus 1. So combine what we can. So now that's gone. So we have 2x plus root x, which can't be combined because this is x to the first. Isn't this technically x to the 1/2? Uh-oh. I am so glad you guys are with it. I am going nuts. So. Okay, sorry. Oh, Jade's me deep. minus the square root of x minus 1. So what I should have wrote was negative root x, like you guys were saying, plus 1, right? So there we go. So we have 2x minus root x plus 1. Now here's what we have to keep in mind. We can't add x to the 1/2 plus 2x, right? This is like a first and an x to the 1/2, technically, isn't it? X to the 1/2 power. Well, you know that. That's what we learned last time. Yeah. Okay, so that's our answer, everybody. And then a lot of people will say, well, which one should I put first, the radical or this? And then I ask them, is 1 larger than 1/2? Yeah, so this is in standard form, highest degree to lowest degree. Now our domain does have a restriction here since there's a radical. Isn't it true in this one? Could I plug in -1? Right here, it'd be fine, but what about here? Square root of -1's I. That is not going to happen. So the restriction comes from there. Isn't it true to say what's underneath the radical needs to be greater than or equal to 0? X must be greater than or equal to 0. So if we're writing it in the advanced format, wouldn't that be from 0 to infinity, including 0? From 0 to infinity, including 0. Okay, great. Let's do g divided by f. So g on top is square root of x minus 1 out here, divided by 2x. Now in this one, that doesn't simplify, does it? We can't do anything here. So that's our answer. We do have two, interestingly enough, in this one, there's two problems. Problem AKA number 1. We can't divide by 0, can we? So x cannot be 0, true? 2 times 0 is 0, and bad news happens then. Second restriction, let's try plugging in -1. I, bad news. Radical as well. So isn't it also true that restriction is x must be greater than or equal to 0? Now let's put those restrictions together. It says x can't be 0. X is greater than or equal to 0. Good, we'll just take off that equal sign. It can't be equal. So x is greater than 0 would be the domain. So if we were going to write that in interval notation, we would say from 0, not including 0, to infinity. Okay, I'm going to have you now do some in that section. Right there. Listen. So everybody, this is an interesting notation here. So it's F and then this little open circle, F, and then a slang word would be FOG of X. Now here is the thing. A lot of people confuse this with multiplication. This is not a multiplication sign. In fact, it's very different. So what this little open circle really means is the word composed. So it's really F composed of G of X. You're going to hear me use the slang word though, FOG, but you'll understand what I mean by composed in just a second. So first things first, I'm going to show you how to rewrite this in a better format. Watch. It's a dumb little trick, but it helps. Take X, squish it back into G. That's G of X. Now squish it in again. That's F of G of X. Does everybody see? Yep. This is a better format. They're equal, but this is a better format, and here is why. So everybody look. If I said to you, here's f of x, find f of 2, what would you do? Yes, you do. What? No. Guys, stop trying to come up with new math rules. Everybody just listen. If I say find f of 2, what am I asking you to do? Plug 2 in for x, right? That means what's my function at 2? So look what I did. I replaced x. I took 2. I replaced x with that 2 plus 1. What is that? All right. Well, now, since we remembered how this works, well, look at this. This is no different. So what are we going to do? Now we're going to take g of x, just like we took 2, and we're going to replace every x with g of x. Does everybody see? So we would locate g of x. We would then plug it in into function f wherever there's an x. You would replace that x, not put it times by it, but replace it, just like we replaced it here. So that would be this, 2 times replaced with x minus 2, and then plus 1. So then we would multiply it in and simplify. So that's 2x minus 4 plus 1, which is, yep, 2x minus 3. So we just composed a new function f composed of function g. Does everybody see? Now, listen to what the word composed means. If I said to you, you compose me some music, you would create music, right? If you compose music, you're creating music. So what we're doing is we're composing function f of function g. We're creating a new function. F will be composed of function g. Does it kind of make sense now? Cool, let's do it. Another one. Go to your homework front page. So number 16, yours says GOF of A. It's fine with an A, but we're going to pretend like it's an X for a minute. So let's rewrite this in the prettier format. Squish X back in with F. That's F of X. Squish it back in one more time. Otherwise, you might get confused and do it wrong on which one you should plug into which one. So everybody, aren't I going to be plugging this one in? F of X into G, correct? Because it's G eating F of X. So locate F of X, everybody. I'm plugging that into function G anywhere that there's an X. It replaces that. Now, when we're substituting or replacing, we need parentheses. So we'd write negative 3x plus 2 over 5. And now because we're not doing anything to the top, we can just drop those parentheses. So G of F of X is negative 3x plus 2 over 5. Pretty easy? Okay. So just watch. I want you to just watch. I promise you you're going to have plenty of time. Watch me quickly do these three because you just need to see better examples. So squish x back in with h. That's h of x. Squish it back in again. G of h of x. So watch what happens. I take h, correct? And I plug it into function g anywhere there's an x. So right there, wouldn't I? So negative 2x squared plus 9 over 5. Still not the best example. That's why I'm going to show you another one. So look at this one. Squish x back in with h of x. Squish it back in again, f of h of x. So now look, I'm going to find h of x. I'm plugging that into function f right there, wherever there's an x. It replaces it. So that'll be negative 3 times by negative 2x squared plus 9 plus 2. So now we would have 6x squared minus 27 plus 2. So 6x squared minus 25. Does everybody agree? Okay, one more. X squash back in with h of x, squash it in again. Squash. H of x. And a function g. I'm going to squash your face. You laugh at me like that again. Squash. I'm just joking. So then right there, wouldn't that be 5 minus, instead of x, we would have negative 2x squared plus 9? So then we would have, distribute the negative, positive 2x squared minus 9, and then wasn't it 5 plus that? So 2x squared minus 4. Does everybody get the idea? Yes. So I just got asked a really great question. Could I do this, everybody? J composed of, like G composed of H? Yeah, absolutely. You could do that. That's already squished, right? It's already squished. So you take H of X, plug it into G, simplify it, plug that into J. Okay, everybody go to 13. There's 2 ways to do this, the long and hard way or the easy way. Watch both. Watch both. So everybody, let's treat this like FOJ of X. So this is the long way. Just watch. Just watch this one. I'm going to teach you the quick way in a minute. We could, instead of 3, treat it like X for a minute. So that's J of X, F of J of X, correct? So now look, I find J of X. I'm plugging that into function F wherever there's an X. So negative 3 times by 5 minus X plus 2, right? So that would be negative 15 plus 3x plus 2, which would be 3x minus. Okay, good. Now, aren't we wanting to do 3 instead of x? So what I could do is go right here and plug in 3. 3 times 3 is? 9 minus 13 is negative 4. Now that was the long way. We got there. Kind of similar to those addition ones, right? We simplified and then plugged it in. But watch how much easier this way is. Let's just go right for the squish. Squish 3 back into J. That's J of 3, everybody. Squish it in again. F of J of 3. Now this is nice because then we can just calculate from the inside out. What's J of 3? Go to J. Plug in 3. 5 minus 3. 2. So that's not there. We're really looking at F of 2 now. So negative 3 times 2, we're plugging this into F, plus 2. Negative 6 plus 2 is? We got there much quicker, didn't we? Let's do another one. 14. Let's do it the easy way. Squish negative 1 back in with H. H of negative 1. Squish it back in again. Focusing, people. So now we'll calculate H of negative 1. Careful, a lot of people can't calculate this, right? Negative 2 times parentheses negative 1 squared plus 9. It would not be appropriate to put negative 2 in there and square it, which I had people doing last hour. Yep, negative 2 plus 9, which is 7. So we're really doing J of 7. We calculated negative 2, all that stuff is 7. No, you can type it in your calculator. We plug negative 1 into H. Negative 2 times negative 1 squared plus 9. Okay, J of 7. That means take that and plug 7 in for J. So wouldn't that be 5 minus 7? So my final answer is negative 2. Okay, go for it. 13 to 24 on the front. I'm getting asked some questions every single hour on the same thing. So I know you know because it's just basic math, but I do understand that we need reminders sometimes. So like, for example, which one was that? If you were doing 5 times g of x, and g of x is x over 5. 5 times x over 5. People think you do this. They think you multiply to the top and bottom, which would be wrong, because that's treating this like 5 over 5. Is it 5 over 5? No, it's 5 over 1. So we multiply straight across. So on top we get 5x. On bottom we get a 5. And so then what does that become? X. So just a good reminder. I've had a lot of people ask that today. Continue. Here we go. Very back. Let's do this one. F of g of negative 3. So I'm going to do it the easy way. I'm going to calculate g of negative 3. 3 times negative 3. So negative 9 is what we're really looking at. F of negative 9. So won't that be 2 times negative 9 minus 1? So that's negative 18 minus 1, which is negative 19. Okay, any suggestions on how to do 7? She's right. Awesome, yeah. Yeah, what do you think? Keep going. Awesome, awesome, awesome. Okay, do it. So we're going to calculate from the inside out. H of 2. So that's, yep, 2 squared plus 1 is 5. So now I go like this. That's 5. G of 5. You guys did awesome. 15. So then F of 15. Yep, 30 minus 1 is 29. So we just calculate from the inside out. You guys did awesome. See, when you see things that are different, but you know how math works, then you don't have to freak out. You guys did really good. Okay. All right, so look at number 10. It says, this one does throw people for a loop. It says f of x. So we're plugging f right back into f again, aren't we? This is a function composition. Now this is what I suggest to do. We write it out twice just to kind of make our lives easier. So we're taking f of x and we're putting it back into f of x. So 2 parentheses, that is replaced with that. 2x minus 1, and then don't we have a? Yep, so our final answer, we would distribute 2 in for x minus 2 minus 1. So f of x is, yep, for x minus 3. What I want you to do is g of x. Ready, set, go. What'd you get on 11? Somebody got 9x, are they right? Yep, right? Guys, you would go like this. G of x equals 3x. We put that right there, which is 3 times 3x. You were right, Stephen. Okay. Do number 12. H of x. I'm going to write this out twice. H of x is equal to x squared plus 1. Now remember, we're taking h of x and substituting it in anywhere there's an x. So wouldn't that be, instead of x, right, instead of that being an x, it's that. Okay, good. Would it be, once again, appropriate to then square that, square that? No, because that's an addition sign. That's the forbidden rule. So you'd write it out. X squared plus 1 times x squared plus 1 plus 1. Yep, good. You guys are awesome. I'm going to keep going for my video's sake, but you guys got it. So you guys can just keep working. X to the 4th plus x squared plus x squared plus 1 plus 1. I do want to say one thing, because real quick, everybody, if I said to you, f of x, watch, this one gets people, x squared plus x, and then I said g of x is x minus 3, find f of g of x. Guess what happens? Let me show you. Same thing though, right? We know how the math works. What should I do? So doesn't it need to go there and there? Yep. So we would do x minus 3 squared plus x minus 3, and then we would go. Okay, cool. Awesome. Okay, I want you to do 1 through 12 on the back. Yep. Cool. A lot of people confuse percent. So before we begin, I want to explain something to you. Now, this is really funny. I used to really think so much more complicated about percents before my mom, who hates math, was like, why do you make it so complicated? Just think of it like this. I'm like, and I've taught it like that ever since. Like, she can't do any math, but I was making it complicated. So everybody, I give you, pretend like a $10 bill right now, right? Everybody, you all have a $10 bill. Now, here's the thing. If I say to you, okay, now I'm going to take off 20% of that $10 bill, a lot of people want to multiply by 0.20. Now, here's why that would be wrong. If you take 10 times 0.20, you get $2. That would not make sense. Didn't I say I was only taking off 20%? So I should have multiplied by 80%. Well, why? Because if I'm taking off 20%, don't you get to keep 80% of that 10 bucks? If I'm taking off 20%. So when I'm saying take off 20%, make sure you use the correct multiplication. Now here's one more thing. If I said to you, if you're good in my class today, I'm going to give you 20% interest on your $10. What people do is they multiply by 0.20 again. But then that's really not what we should be doing, because that's $2. Yeah, good point. Instead, what you're going to multiply by is 1.20. Now here's why. Yeah, you're getting that full 100%, of your $10 back, right? Plus 20 more percent. So just be careful on that. Yep. All right, so everybody, let's read this problem. And if any of you go into business, this is exactly what you're going to be doing. So everybody listen. Don't talk. It says a video game store. So you're all pretend like you're opening up a video game store. Now think about it. When you're you're opening up a video game store, you have to go out and purchase all the video games, right? But now you're going to want to sell those for more than what you paid. So let's call X the cost of the video games for us as business owner. Now it says we are going to add up 25% markup on each of the games. So we're going to sell these games for 25% more than what we purchased them for. Does that make sense? Okay, so what am I going to be multiplying by? 1.25 is my rate. Okay, so now it says, well, also, it costs for shipping $1.50. Now think about it. If you purchase online clothes, the company is going to charge you the amount that they paid plus more, and then they're going to charge you for shipping, correct? All right, so let's read part A. It says, write a function to represent f of x per video game after the stored's markup. So write f of x is equal to the cost times by 1.25. Isn't that the price after the markup? Now in part B, it says write a function g of x to represent the manufacturer's cost plus the shipping charge. So what should I do? It says it costs $1.50 for shipping. Same thing. This would be the cost to the person, technically, correct? Plus $1.50 for shipping. Does everybody get it? Now here's what's interesting. There actually has been companies to get sued for doing what part C is asking us to do. So what happens is, can't I, as a store, secretly take that $13, add the shipping first, and then times it by 1.25? If I do that, aren't I going to make more money because you're also charging them interest here? Okay, so let's see. It says in part C, suppose it's $13 and you apply the shipping charge first. How much money would that cost for the person? Ready, go. Take 13 in your calculator plus 150 and then times by 1.25. So 18.125, so that would be $18.13. That's how much they're charging if they're secretly charging you interest on your shipping. But in part D, it says, let's just do this the correct way, basically. Let's do this charge and then add shipping, which is really more fair for the consumer because you shouldn't charge them interest on shipping, right? So do that one. You'll type it in directly right here. 13 times 1.25 and then add the shipping after that. So now think about it. This is cheaper for the consumer, obviously. So yeah, this might be better for the business owner, which you're thinking, well, that's not that much money. But when you have thousands and thousands of customers, that adds up quick. So there has, like I said, been companies to get sued over this. But there are companies that also put it in the fine print that they're going to charge you their markup after shipping. So you just have to watch. So anyway, the people that got sued are the people that didn't have that in their little small fine print. Does that make sense? Okay, kind of cool. So that's how that is. That was very realistic. Like you didn't have to think that hard about it. So guys, I want you to finish the entire worksheet. The story problems are very similar. But make sure you think about rates. Should I be multiplying by 0.80 or 0.20? And so on.